Hi everyone, my name is Khánh and I'm a product manager at Google Cloud working on generative media. In this video, I would like to give you an introduction about generative media, which are the AI models that allows you to generate images, videos, and audios from a text prompt. In Google Cloud, we offer 4 Gen media models: Imagen for image generations, VO for video generations, Chirp for speech generations, and Lyria for music generations. For each model, I'll go through the popular use cases that many developers are leveraging them for. Then I'll talk about the technical details on how you can get started with using this model. Now let's dive into it. We'll start with Imagen. The most basic use case that you can use Imagen for is to generate high-quality images from a text prompt. It can generate many different kinds of images, like photorealistic images, which would be very difficult and costly to capture in real life, such as this drone photo, or this photo of a hummingbird. Imagen can also do macro photography and creating very realistic and artistic lighting condition. Imagen can also generate science fiction images or images of different art styles. Beyond generating images from text prompts, Imagen can do image editing as well. It can remove objects from the image so that it can turn this photo into a beautiful photo of just you. It can remove reflections on windows as well to make a picture-perfect photo. Besides object removal, Imagen can also insert objects into images or extend an image and fill in the missing areas. These features can be used to correct photos taken at a bad angle, for example. Imagen can even completely replace the background of the photo, making them more interesting. It also can stylize your image into many different art styles, including oil painting, 3D art, and many more. The background replacement features is actually quite useful in e-commerce as well, because you can generate different backgrounds for your product image. It works for a wide range of products, from small items like this perfume bottle, to big items like appliance or furniture. So that was a highlight of features that Imagen offers. Now let me show you how to use Imagen in code. Imagen has a RESTful API which is available through Google Cloud. You can call the REST API directly from your applications, or you can use one of our GenAI SDK to make it easier. Next, let me show you how to use Imagen with the Python SDK. You start with installing the Google GenAI SDK using pip. Then you will need to authenticate your environment. If you are using Google Colab, you can use its auth module to do it quickly. If you're using a local Python environment, you can use a zcloud CLI, run this command, and authenticate with your user credential. Then you need to create a GenAI client. Next, you define the text prompt that you want to use. Then choose an Imagen model. Here we choose Imagen 3 Generate 002, which is the latest and highest quality Imagen model as of May 2025. And just call Generate Images, wait a few seconds for it to generate, and then save the generated image in a file. Very easy, isn't it? There are several parameters that you can use to customize your image generation request. For example, you can choose how many images you want to generate in a single request. You can choose any value between 1 and 4, and if you choose to generate more than one image, you will get multiple variations and pick the one that you like the most to use. You can choose the aspect ratio for the generated images as well. So that was image generations. Now let's talk about image editing. To edit an image like this with Imagen, basically you need to define a mask which tells Imagen which part of the image that you want it to edit. If you want to remove the objects from the image, then the mask is all you need. But if you want to insert objects into the image, then you need a prompt to specify what to insert. The Python code to do image editing with Imagen is very similar to the image generation code that you saw earlier with a few changes. First, you need to import a few more types from the GenAI SDK. Then you define the original image and the mask image. Then you call the edit image functions. You specify the editing mode to use here. For object removal, you don't need to write a prompt. But to insert an object, you need to specify what you want to insert in the prompt. And finally, you save the output image to a file, just like what you did earlier with image generations. Very easy, isn't it? Please also check out the Imagen Colab notebooks in the video description for more examples of how you can use Imagen to generate and edit images. Now, let's move over to Veo, our video generation model. Veo 2 creates high-quality videos covering a wide range of topics and styles. In fact, when we compare it to other video generation models, people consistently rated Veo 2 as producing better results. Veo's most basic features is to allow you to generate videos from text prompts. As in May 2025, you can generate videos of up to 8 seconds. Just like Imagen, Veo can generate many different kinds of videos from photorealistic, science fictions, animations, and many more. You can have more control over the output video by using an image as the initial frame and writing a prompt to turn it into a video. Because generating an image is faster than generating a video, this approach allows you to quickly iterate to get the visuals that you want before turning them into a video. You can also specify different camera movements, such as panning left and right or pushing in, to have more control over the output video. One interesting use case of image-to-video capability is to turn a static banner ad like this popcorn ad into an engaging short video ad like this one. Veo API is also available through the Google GenAI SDK, and let me show you how to use it in Python. You start with installing the same Google GenAI pip package, then import the GenAI module and initialize a client object, just like what you did with Imagen earlier. Next, we'll use a model called Veo 2.0 Generate 001 for text-to-video generations. Similar to text-to-image generations with Imagen, we define the prompt, the aspect ratio, the number of variations we want to create, and the length of each video. After calling the generate video functions, you will get back a long-running operations, which you will need to call it periodically and wait until the video generation operations has completed to download the video. It will take about 20 seconds to generate a 8-second video. Once it has completed, you can save the generated video. If you want to specify an image as the initial frame for the generated video, you can do it by defining the image and then pass it to the generate video function. The other parameters stay the same. Okay, so that's all you need to generate videos with Veo using the Google GenAI Python SDK. Next, let's talk about Chirp, our latest speech generation model. Text-to-speech technology has been there for many years, but our latest text-to-speech model really improved in how natural it sounds and the level of control you have to infuse emotions into the AI-generated speech. So why don't we just let Chirp introduce itself and tell us what it can do?
Hey there, I'm Chirp 3. Well, one version of me anyway.
And I'm Chirp 3 too, just with a different voice. We're here to tell you about how incredibly natural sounding we are.
Yeah, we're not those robotic voices you're used to. We can actually, talk like real people, with pauses and, even the occasional
It's true. We've been designed to really capture the flow of conversation. We can handle complex sentences, different tones, and get this, we support 30 different languages.
30? It's kinda crazy. We're talking English with different accents. German, Indonesian, Spanish, Chinese, The list goes on.
Imagine reaching a global audience, all with incredibly natural-sounding speech in their native tongue. We even support different accents within languages, like speaking English with an Indian accent.
So whether you need a voice for customer service, e-learning, or, well, just about anything, Chirp 3 has you covered. We're versatile, natural, and ready for anything.
Give us a try. We think you'll be amazed at how human we can sound, without actually being human, of course.
Yep, we're pretty good. Thanks for listening.
What do you think? I think Chirp 3 sounds really natural. Next, let me show you the code to generate speech from text. In order to use Chirp in Python, you need to install the Google Cloud Text-to-Speech SDK using pip. Then you import the text-to-speech module and create a text-to-speech client. Now let's move on to configuring the speech generation task. You start with selecting the voice you want to use and the config of the output audio, such as which audio encoding you want to use. Then specify the script that you want Chirp to read out. Finally, call synthesize speech functions to start the model inference. And once it has completed, you can save the model output as a file. That was all you need to generate natural voice using Chirp 3. Lastly, let's talk about Lyria, our latest model for music generation. The main thing Lyria does is to create instrumental music based on a single text description. You give it a prompt describing the mood, genre, and instruments that you want, and Lyria will generate the music. We're not doing vocals yet and focusing on instrumental tracks. Think of it as describing the kind of music you need, and Lyria will generate it for you. Before we get into how people are using Lyria, I want to play a few quick examples of music that it has created. As you can tell, the range of styles is pretty broad, even within the instrumental space. These are just examples generated from text prompts and not from pre-recorded music at all. You can use Lyria for many different use cases. For example, a game developer may need to create unique background music for different levels. They can use Lyria to quickly generate tracks that perfectly match the mood and setting of each level, saving them time and money on custom compositions. Podcasters could use Lyria to create intro and outro music, or even background music for specific segments. They could easily generate royalty-free music following their podcast theme and tone. Meditation apps could use Lyria to create personalized music experience for each of their users. They can customize the prompts to evoke specific emotions or memories. Okay, so far I've shown you how to use each ZenMedia model individually, but actually, you can do more than that. I'll show you a workflow to combine all 4 models together to create longer videos for many different use cases: video ads, visual storytelling, short movies, you name it. The typical workflow would start with writing a storyboard for your e-video. You can use Gemini to have you brainstorming or writing the whole storyboard based on your idea. Here's my storyboard for a short ad video for an imaginary coffee brand, which consists of 6 different scenes. Then you can use Imagen to generate the first frame for each scene. You can iterate on it until you get the visual that you like. After that, you use the VO image to video feature to generate a short clip for each scene. Then you use Chirp and Lyria to add music and narrations to the video. Now, let's take a look at the premium coffee video ad that I created using this workflow.
Premium Coffee selects only the top 1% of fair trade Arabica beans. slow roasted, perfectly brewed. Releasing notes of chocolate and spice. Premium coffee, the taste of true distinction.
I hope that you liked the video. To recap, we talked about 4 generative media models today. Imagen for generating images, Veo for generating videos, Chirp for generating speech, and Lyria for generating music. You can find the Colab notebook showing how to use the models in the video descriptions. Please check it out, and I'm looking forward to seeing what it will create using these models. Thank you for watching.